Dear students, 2025 JEE Mains Phase 1 exams are happening till today. Tomorrow is the last exam. I have gone through all the papers and I analyzed the papers. No two papers are same. And topic-wise analysis I made. And after coming to conclusion, what are the leftover models topic-wise standard point of view? Those problems I listed. And some of the problems I'll discuss here. So this first question in optics, glass plate of thickness 2 centimeter is optically equivalent. What is the meaning of optically equivalent? So here optical path of medium is nothing but distance traveled by light in vacuum in the same time. Suppose in one medium light is traveled, then time taken to cover this distance is velocity of that light in medium. So here velocity of that light in medium is nothing but c by refractive index of the medium. Time will be c mu. And in this time in vacuum, how much distance it travels d1, which is optically equivalent to traveling distance d in the medium. That is c into d mu by c. So optical equivalence is mu d. Here 1.6 into 3.2, which is same as 2.4 into 4 by 3, 3 point. So the first option is correct. Here, unit vector along incident, unit vector along the refracted ray. N is normal to the boundary of the medium directed towards the incident. Then law of refraction. Law of refraction, all of you know, mu1 sine I1, it is mu2 sine R. You take just modulus and observe it, you get this formula where n cap is a unit vector, modulus of n cap is 1. And here point source of light is placed at the bottom of water lake. Here, if the area of illuminated circle on the surface equal to 3 times the square of the depth of the lake. Here d is the depth of the lake, r is the radius, and what he given is circle 3 times the square of the depth. Pi r square is 3 times square of the depth. How do you get some region is illuminated? So light, when it travels from water to air, at some point of incidence, it's completely reflected. So here it is, that is 90 degrees. Mu sin c is equal to sin 90. Sin c you get 1 by mu. C is called critical angle. So sin c will be r by h. So sin c here is 1 by mu. Sin c is, tan c is r by h. And sin c is 1 by mu. That's tan c will be 1 by mu square plus 1, which is squaring, and use this relation, you get the required answer. So a ray of light incident at an angle 60 degrees on the prism. It is angle made by the incident ray with the normal. It gets refracted and then further it gets refracted from other surface normal. This will be the deviation. That deviation is nothing but here this one is R1, this one is R2. That is nothing but this part, which is total 60 minus R1, this part. And this one is angle of emergence. Angle of emergence minus R2, which is deviation. So 60 plus C minus R1 plus R2. We know that R1 plus R2 is A. 60 plus C minus. The given refractive angle is 30. Deviation also. Emerging ray 30 degrees with incident means that is this is incident ray, it is emergence ray. That is deviation, which is 30, which is equal to 30 plus C. So angle of emergence is 0. So angle of emergence is 0. Then if you apply Snell's law for this surface AB, 1 into sine 60 is equal to, so mu into, so once emergence angle is 0, this becomes angle A. So that is mu sine 30 is equal to sine 60 root 3 by 2. From here, mu becomes root 3. Now, next question is, the refractive index of violet and red. If the angle of prism is 10 degrees, then angular dispersion. So angular dispersion will be calculated by using a formula mu v minus mu r into difference 0.2 into 10, which is 0.02, sorry, 0.02 into 10, you get 2.2. And here glass prism deviates the red and blue rays. Then dispersion will be calculated by using delta V minus delta R by delta Y for first class prism omega 1, for second class prism by delta Y. So here it is 12 minus 10, delta Y will be average, that is 10 plus 12 by 2, 11. Here 12 minus 2, 10, 2 by 11. Here it is 10 minus 2 by average, 9. This is W2. So W1 by W2 will be 9 by 11. So another important question here. When it is once it is a convergence length, F will be greater than 0. So focal length of a lens, mu relation, mu r minus 1 by r1 minus 1 by r2. Once it is converging lens, r1 is positive, r2 will be negative, so that this will be positive. So f is greater than 0 means mu r minus 1 greater than 0. Mu r means we can write mu glass by mu a minus 1, that glass refractant that is when it is in water, that means in place of r, mu glass by mu water minus 1, refractive index of water we know 4 by 3. So mu g is less than 4 by 3. So this will be the answer. Here, an equiconcave lens, power minus 5d, cut into two equal halves along the principal. So once it cuts along this is concave lens. So there is no change in the focal length because, so once you cut it also, radius of curvature, no change. So R1, this in this 1 by R1 minus 1 by R2, there is no change for. So here I can write the power will be 100 by focal length. Initially, power is minus 5 diopter. Focal length will be 100 by 5. But we get minus 20, right? And another similarly, uh, for next one also we get same thing, and they are separated by distance. Then focal length, the effective focal length will be calculated by using a formula this 1 by minus 20, 1 by minus 20, and F1 F2 D here is 10, F1 F2 will be 20 into 20. So here you get minus 2 by 20. So here you get minus 5 by 40. Effective length will be. So you can expect this question for next exam. So in wave optics, till now he is not given a problem based on introducing mica sheet in the path of light rays. So once he introduced mica sheet, so central fringe, bright fringe will shift by a difference. How much? What will be the phase angle? 2 pi by lambda into mu minus 1 into t. So here path difference after introducing mica plate, path difference becomes mu minus 1 into. It is phase difference is this much. Now what he's asking is intensity of the center of the screen. Now actually double slit experiment, here path difference is 0. Here you will observe a bright fringe. When mica plate is introduced, it shifts, bright fringe position shifts by some distance. That doesn't mean that here dark will be there. Here you have a bright fringe. So here brightness, but maybe here let uh, here brightness is lesser than brightness at this point. So first bright fringe is here doesn't mean that here dark fringe. There will be some intensity at the center. What is that intensity? We have to find out. So how do we find intensity means? Intensity will be calculated by using formula I maximum into cos square delta phi by 2. Right. So what is delta phi? will be 2 pi by lambda into mu minus 1 into t. That thickness mu value he given 3 by 2 minus 1 half, which is nothing but pi t by lambda. Right. So here it is. Path difference is d sine theta is n lambda. So here it is. Sine theta is same as tan theta, which is y by, here is, this is y by capital D, it is slit and it is screen, which is n lambda. Place slit required to reduce intensity at the center of the skin by half the maximum intensity. So from here, 1 minute, from here, intensity is half means cos square delta phi by 2 is half. So cos delta phi by 2 will be 1 by root 2. Delta phi by 2 will be 45. Delta phi is 90. And that delta phi here is path difference mu minus 1 into t into 2 pi by lambda. So mu value is already given. The delta phi is pi by 2. It's half t to lambda. So pi pi get cancelled. So what we get here is t is lambda by 2. So that is answer is third one. Two coherent sources of light placed at minus 5a by 2, 5a by 2. Wavelength of the light, how many maximas will be obtained on a circle of large radius with center at the origin? So here through given points, maximum circle. So how many maximas are obtained means, let us take a circle here. Here you have minus 5a by 2. This is 5a by 2. Here is a point. So if we drop a perpendicular, this becomes a path difference. Let us take this angle as theta. This distance is 5a. Mm, So this is perpendicular. Then this difference will be d cos theta. Here is an angle theta. This angle is theta. This perpendicular. This is the path difference. So cos this will be cos theta is x by d. Path difference will be d cos theta. If d cos theta is n lambda, we get a bright fringes, we get maximas. That d here is 5a by 2. Here it is. In fact, this we want, that is 2d cos theta, which is here it is 5a cos theta. N lambda will be 4a by 3. Cos theta is 4n by 15. So for n is equal to 0, 1, 2, 3, right? For this you get bright fringes. Obviously, once you get here this side bright fringes, here also -1, -2, -3. Here also you get total 7 fringes in semicircle. Another 7 total. 14 maximas will be obtained on a circle of radius with center at the origin. So here it is. How many maximas are obtained means d sine theta is n lambda. N lambda by d is sine theta, which is lambda here is d by n, that is 700 by 200. You take integral part, you get 3 bright fringes. In fact, it lies between -1 and 1. That can be 0, -1, -2, -3. Total 7 are possible. Here, maximum electric field of a plane. And what is average density? How do we calculate? By using half epsilon naught E square. You know epsilon naught value 8.85 into 10 power minus 12. And electric field he given already, just substitute, you get this. Here, parallel plate condenser has conducting plate of radius separated by distance. Then capacitance of that parallel plate capacitor. You can calculate area means 5 into 12 by 100 whole square. Epsilon naught value, you know it, right? And already written there. And the distance is 5 mm, 5 into 10 power minus 3 whole, uh, 5 into 10 power minus 3 meters. Then by using that, you can calculate capacitance. It is charged with a constant charging of current, 0.16 ampere. The rate at which Q here is CV. dq by dt will be C dV by dt. He is asking rate at which potential. So dV by dt will be dq by dt by C. So he given already charging current 0.16. Here you can calculate capacitance and substitute. You'll get the required answer. So the wave impedance can be calculated by directly formula mu by epsilon. He given relative permeability and epsilon value, you know it, substitute you can calculate. Intensity of a wave will be calculated by using 2 mu naught. Everything magnetic field is given. Velocity of light permittive. So mu naught value, you know it, 4 pi into 10 power minus n. So these models are not covered. In EM wave, what he given is wave equation based problems he given. Most of the questions are, and he given E naught is equal to B naught into C, these kind of problems. He is not given problems based on these models. Most probably he can ask a question based on this in the next exam. So here in case of waves, the tuning forks are sounded together, produced 5 beats in 2 seconds. So, so time interval, what he is asking, which is equal to 1 by beat frequency. So beat frequency will be 5 beats in 2 seconds. 1 by 2.5, 0.4 seconds. Right. These are all standard questions everybody might be knowing. So AC currents, the peak value of AC here is 2 root 2A. Apparent means RMS. IRMS will be I 2 root 2 by peak value by root 2. IRMS is I naught by root 2. IRMS, what we call it as apparent value, which is 2 root 2 by. root to you get 2 amperes. Alternating voltage is connected to a condenser of 1 microfarad through AC ammeter. Reading of the ammeter. How do you calculate reading of the ammeter? I will be V by Z. So mm, what he given for this condenser capacity, the condenser, so battery is connected to capacitor. Then Z will be uh, that is XC, V by 1 by omega C, V into omega C. Right. So with the help of this, we can omega, you know it, mm, peak voltage, you know it, and capacitance, you know it, substitute, you get it. Here in this coil is connected to a generator and it is found to be, current found to be this, the potential difference across the, so it is a LR circuit. Impedance will be calculated by using R square plus XL square. R square plus omega L square. L he given. He is asking frequency also given. You can calculate 2 pi of L whole square. F is given, L is given. So resistance we have to calculate. And so how do we calculate resistance? So potential difference across the resistance means IR. So R we have to calculate and it's already current is found to be this. And impedance uh, so Z here is V by I 50 by zero point 0.5. So it is 100. From Z we calculated. From that R you can calculate. Once you calculate R, IR will give you potential difference across it. So based on energy band description, solid can be insulator means obviously energy gap is more. That is thus. In PN junction, uh, there is a potential barrier. Once it is reversed biased, so it is connected to positive terminal. Then P junction is uh, P is connected to a negative terminal, and here so majority of charge carriers move towards right, here towards left. So this potential barrier increases. So Jenner diode, here let us say this is AB, breakdown voltage, potential difference across BC is 15 volts. So here it is potential difference across AB 20 minus 15, 5 volts. So then the current through this resistance is, so I here is 1 by 50 amperes. And here 15 volts is through this resistance, load resistance, how much current? 10 cube. I will be 15 by 10 cube amperes. The current through the diode will be, so 1 by 50 minus 15 by 10 cube will give you the current through the resistance. Here I current that is distributed to diode, I will be ID plus IR. ID will be I minus IR. That gives you the current through the diode. When in heat part, Here, three rods of equal length are joined to form a equilateral triangle. D is the midpoint of AB. This length, let us say D. Here A, it is A by 2. D square will be A square minus, that is 3A square. The coefficient of linear expansion is alpha 1 for AB. And now alpha 2 for AC. So DC remains constant for small changes in temperature. Maybe AD changes, maybe AC changes, but D remains constant. So new AC will be A into 1 plus alpha 2 delta T. New AD will be A by 2 into 1 plus alpha 1 delta T. So now D square you can calculate A square 1 plus alpha 2 delta T whole square minus 1 plus alpha 1 delta T whole square. Delta alpha 1 is very small. You can write 1 plus 2 alpha 2 delta T minus A square by 4 1 plus 2 alpha 1 delta T. So here it is 3s, this D square and D square simplification. 2 alpha 2 delta T is equal to 2 alpha 1 delta T. Then you get alpha 1 as 4 times alpha 2. And here it is. During experiment of a ideal gas, the given Pp square is constant. The gas initially at temperature T volume when it expands to the temperature. So we want relation between temperature and volume. P here is n of T by V, n square R square T square by V square is right. Uh, it is constant. What here? nr is constant. T square by V is constant. So T1 square by V1, T2 square by V2, V2 is to V1. Temperature changes to this. And during the adiabatic process, the pressure of a gas is proportional to cube of temperature. Pt power minus 3 is constant. We know that PV power gamma is constant in adiabatic process. In terms of V is nRT by P, T power gamma by this. So between P and T, this is the relation. Or you can raise Pt power gamma by 1 minus gamma constant. Gamma by 1, this gamma here is minus 3 plus 3 gamma. Here you get minus 2 gamma is minus 3. Gamma value is 3 by 2. So all the best for students who are attempting exam tomorrow.